Hey, welcome. My name's Steve, and we're doing the Senior Maths Challenge from 2019, from 2 years ago. We've already had a go at the Junior one and the Intermediate one. You are welcome to have a look at those on my channel. But if you want to have a go at the Senior one with me, you can watch me do it, and I'll be talking through different strategies and tips and how I kind of approach the problems as we go. But if you want to have a go at it yourself, if you look at the link to the YouTube video, you can get that paper yourself. Have a go, pause this video and come back to it, and we'll see what we get at the end. If you get a score at the end, you can put it in the comments of the video and you can see how well you do compared to what I get. This is a 90-minute test, or I'm going to call it a 90-minute bit of fun, where the questions get increasingly harder. And the way the scoring works, if you've not done one of these before, is it's slightly different for the senior one. You get 4 marks for every question you get right, and you get 1 mark for every one you get wrong. You start with 25 points. So if we get everything right, we will get 125 marks. However, every question you answer and isn't right, you'll lose your mark, but you can leave them blank. So if you're having a go at this in real life, and you didn't know one, I would suggest you leave it blank. There's some nice maths there. If you're the kind of maths person who really likes your maths, there's some really interesting questions, and often there is an elegant way to do nearly every one of these questions, nearly every one. A little trick, a little think, and I won't find that on everyone, and for that reason I might struggle to do some of these. In limited time I could probably get you an answer, but with 90 minutes I'm going to try and keep the video to as close to 90 minutes as I can. Might not get them all done. So my aim is out of 125, I'm looking for a score over 100 and hopefully over 110, but we will see. I would suggest if you're doing this in real life, you focus on the first 15. If you are going to sit this as a student, unless you're the sort of person who's done these before and gets lots right, you want to focus on the first 15 because that's where the easier ones will lie. And thereafter, the 10 after that, if you think you're going to run out of time, just pick the ones you think you can start. If you don't understand the question, don't sit there gasping over it. Just come back to it at the end if you've got time, but don't guess. Right, off we go. Good luck. Alright, so question number 1. What is the value of 123 squared minus 23 squared? There is an obvious way that I've seen to do that. You could just work them out separately, but that would take you time. But we notice that that is a difference of 2 squares, so we can say that that's the same as 123 plus 23 multiplied by 123 take 23. Let's factorise that into a difference of 2 squares because they're both square numbers, and that gets you 146 times 100. That makes it a lot easier. So 14,600. What was the value of all of that? 2019 take in brackets 2000 take in brackets 10 minus 9. And subtract. You can read it. I'm not going to read that out. So we're going to have a go at doing this, and hopefully I don't drop a negative. 2019 take 2000 take 1. So that's the first bracket. I've just done 10 take 9, and we're going to subtract 2000 subtract 10 subtract negative 2010. Okay, so this is going to be 2019 take 1999, which is going to be 20. And we're going to subtract. This is going to be negative 2000. Subtract positive. This is going to be 2020, and we're going to 2000 take 2020. I've done something wrong. 2000 take 2020. Is going to be, oh dear, I need to wake up today. 2000 take 2020 is negative 20. It's going to be 20 subtract negative 20. There we go, we get an answer that's there. I was stumbling because I thought I was going to get an answer in the region of about 2000, but obviously I was missing a negative there. Used in measuring the width of a wire, 1 mil is equal to 1,000th of an inch. An inch is about 2.5 centimeters. Which of these is approximately equal to 1 mil? So it's 2.5 divided by 1,000. So that's an inch, and 1,000th of an inch gets you a mil. So this is 25 over 10,000, which is 1 over 400. Oh, hang on. So that's centimetres. Oh, that's centimetres, and I want the answer in millimetres, so it's going to be 1 out of 40 millimetres. It's a good thing they didn't have that as a wrong answer. Otherwise I might have gone wrong now. For how many positive integer values of n is n squared plus 2n prime? It's either going to be none or a very specific answer, or it's going to be infinite. So I don't think this is going to be an option I'm going to pick. What can we do here? How about if we factorise? And then for this to be prime, n has to be 1. So if n is anything else, you're going to get 2 factors, and n has to be a positive integer, so n can't be 0. So if n was 1, you'd get 1 times 3 is 3. So that works. And if n was 2 or larger, you're going to get a factor of n, and a factor of n plus 2, you're going to get 2 factors to whatever number you get. So I think it's just 1. Olive Green wishes to colour all the circles in the diagram so that for each circle is exactly 1 circle of the same colour joined to it. What's the smallest number of colours that Olive needs to complete this task? Well, there's an even number, so my guess, if you did black, 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 blue, 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 for each circle there's exactly 1 circle of the same colour joined to it. That's true, isn't it? So 2. Each of the factors of 100 is to be placed in a 3 by 3 grid, 1 per cell, in such a way that the product of the 3 numbers in each row, column, and diagonal are all equal. The positions of the numbers 1, 2, 50 and x are all shown. What is the value of x? So the factors of 100, you've got 2 50s, 4 25s, 5 20s, and then 10 10s. So here's the 9 factors. You've got 10 times 10, which means that because you need the products of all the columns, rows, and diagonals, what you want is 10 in the centre, probably. Because then either side of 10 are all your factor pairs, so that'll be 100. And then the product is 1 times 10 times 100 is 1,000. 2 times 10 times 50 is 1,000. Which means 2 times 100 is 200, so you need that to be 5. You need that to be 4. Opposite 5 is 20, so we think that's 20, and we think that's 25. 2 times 25 is 50, times 20 is 1,000, so we think x is 20. Usually with magic squares, the middle number of the lot usually goes in the centre as well, so it's not quite a magic square, but that was a decent guess that 10 would go in the centre. Lucy is asked to choose P, Q, R and S to be the numbers 1, 2, 3 and 4 in some order so as to make the value of P, Q plus R, S as small as possible. So, to make this as small as possible using 1, 2 and 3 and 4, we just have to add them together, work out what it is. So to make them as small as possible, we're looking for the fractions to be the smallest type and the amount of those fractions to be small. So we're either going to have 1/3 plus 2/4 or 2/3 plus 1/4. My guess is that of these two you want the fewest of the larger fraction. So 1/3 is bigger than the 1/4, so you want less of them. And then this is going to be 4/12 plus 6/12 is going to be 10/12. or 5/6. I think if I had time at the end, I'd come back and check a couple of other possibilities if I wasn't sure. Yeah, they can do. Yeah, basically, well, if you change these down to prime factors, so you've got like 2, and then this is 2 squared times 2 squared times 5 squared, and this is 5. You just need the same factors in each column and row. So in each row, you need 3 2s and 3 5s. Is that right? So it's 2 5s, 3 5s, a 2 and 2 2s. Number x is a solution to the equation 3 to the power x is 333. Which of the following is true? So I'm just going to hide that for the moment. 3 to some power is 333. So if we do powers of 3, so 3, 9, 27, 81, 243, 700 and something. So 1, 2, 3, 4, 5, 6. We think we want the power to be a bit over 6. So to make this power a bit over 6, we want it to be in here, 3 to the power. So somewhere a bit over 6, but not 7. Yeah, so 6 and a bit, so not 7. So between 6 and 7 is between 3 and 9. So we would want 3 to the power something to be between 3 and 9. So I think we want x to be between 1 power of 3 and 2 powers of 3. So I think it's that one. I don't think I explained that very well, but hopefully you could see what I was talking about. For 3 to some power to be 333, you need the power of 3 to be 6 and a bit. Because this is 3 to the power 6, this is 3 to the power 7, so 3 to the power 6 and a bit is going to get you 333. So we want 3x to be 6 and a bit, so all that does is going to change 6 and a bit. And then we're going to do the same thing. If x is 2, we've gone too far, and if x is 1, we haven't gone far enough. So it's going to be between 1 and 2. Alright, this is a visualization one. These can be hard to explain, potentially. This is a folded, so you're folding a, go away Discord. We're folding a piece of paper in half 4 times to obtain this, and then you're cutting a corner out. Which of the following could be the paper after it's unfolded? So I think this is going to be hard. So if I unfold it once, you've got that. If I unfold it twice, you've got that. If I unfold it 3 times, you're going to have effectively 2 circles. And then if you fold it up again, you'll get, so that's after 4 folds. I think it's going to look like that. So I think it's D. I'm just going to close Discord so I don't keep getting interrupted. Not that one, that one. Right, here we go. Which of the following 5 values of n is a counterexample to the statement in the box below? For a positive integer n, at least one of 6n minus 1 and 6n plus 1 is prime. So what we're looking for is a number that when you times it by 6 and then take 1 and add 1, you don't get 2 primes. I'm just going to have to work this out. So that's going to be 59 and 61. That's prime, so it's not that one. This is going to be 113, 115. That's prime. 20 is 119, 121. That is 11 11s. That is 7/17, so it's 20, I think. Just double check. 21 is going to be 125, 127. That's is that prime? No 7, no 9, no 11, no 13. No, yeah, that's probably prime. And 30 is going to be 179 or 181. Oh dear. I think it's this one because I think that is 7/17s. 70 plus 49, yeah. And that's 11/11s. Yeah, you don't know your primes begin 17ish. I know them all the way up to 100, and then it gets a bit ropey. So in this particular case, I'm looking for factors. So I imagine one of these is prime. I mean, it makes sense that n's an even number, because then you'll get two odd numbers, and you might like to get primes of odd numbers. I suppose no, because they're all going to be odd numbers, aren't they? Because you times them by 6. Yeah. Okay. I think it's C. I don't like the question. There might be an elegant way of doing that. For how many integer values? Integer means whole number, but you should know that if you're doing a maths paper as hard as this. Yeah, my tables are pretty good, just from years of doing them. For how many integer values of k is the square root of 200 minus the square root of k also an integer? So I know that 196 is 14 squared. So my guess is it's 14, but that's not an option. Effectively, what you do for k is you can have k is 196 squared. Apologies the way around. You do k is, oh, you want the difference to be, so you want k is, so the first square number you can get to is 196, so you want k is 4 squared. And the square root of 4 squared is 4, 200 take 4, it's 196, and that's square roots. And then the next one you want is 169, so you'd want k to be 31 squared. And that gets you 14 as an answer, 13, 12 all the way down. Oh, you could get 0. So you could have k, the last one you could have k is 200 squared, and you'd get 0 as an answer, and you could have k is 199 squared. Gets you 1. Yeah, so I think it's actually, it's one of these ones, if they'd have put 14 as an answer, I'd have probably just gone 14 and wouldn't have thought about it. So I think they've been very nice today. Sometimes they give you bad wrong answers, or good wrong answers. A circle with radius 1 touches the sides of a rhombus as shown. Each of the smaller angles between the sides of the rhombus is 60. So that's 60, so that's 60. I'm going to just make it a bit bigger, just so if I have to write in it. So let's just in case I have to write in it. So there we go. We've got a larger one. The circle with radius 1 touches the sides of the rhombus as shown. Each of these small angles is 60, so that's also 60. What is the area of the rhombus? So the circle has a radius of 1. So we know there's a line there, and there's a line there that go through the centre that meet at right angles. Ugh. So that's a right angle, that's a right angle, and so on. And these are straight lines that go through the shape. Because this is parallel to this, then the tangents are parallel, which means they both go through the centre. So this is 120, so that's 60. 120, 60. and these are all length 1, 1, 1, 1, and 1. So you could do this is, I mean, I do not like this, but you could split it into, oops, that, because this angle's 30 and it's a right angled triangle, this is 60, and because sine 60, sorry, cos 60 is a half, or sine 30 is a half, you know that if this is 1, this is 2. You can give tips. I think I've got this one, Tim, but you also can give tips. If I get to a point where I'm stuck, of course you can give tips. That's 1, that's a half. That's 1, that's a half. So I think you're going to have 4 triangles that is a half by 1. So you're going to have 4 lots of a half by 1 by a half, because base times height divided by 2. And then you're also going to have 4 larger ones, which is 1 by 2. So you can have 4 triangles that are 1 by 2, and then base times height divided by 2. So I think it's going to be one of the first 2 options. I don't think you've got any roots there. 4 times a half is 2, times 1 times a half is 1. 4 times 1 times 2 is 8, times a half is 4. I've done something wrong. That's not right. All the 2's are root 3's. Am I doing stupid? Am I being stupid? If you have a triangle, I got the length wrong. So if you have a triangle, that is 30. Oh, the hypotenuse is 2, so this is root 3. Thank you very much. So all the 2's are root 3's. So this half will be 1 over root 3. And this 2 will be root 3. So that's going to get us different things. That's going to be 2 over root 3 plus, thanks very much. I had the right method, I just got the wrong side to the wrong angle. I might have spotted that because the answer I got wasn't there. 4 times a half is 2 root 3. So this is going to be 2 root 3 over 3 plus 6 root 3 over 3. It's going to be 8 root 3 over 3. Yeah. Cheers, AJ. Anish has a number of small congruent squares used to tile in that he uses to tile in a mosaic. When he forms the tiles into a square of side n, he has 64 left over. When he tries to form the squares into side n minus 1, he has 25 too few. N plus 1. So I think we had a very similar one to one we did the other day. So it's going to be the number of tiles divided by n is n with 64 left. And then the number of tiles divided by n plus 1 is n plus 1, but 25 too few. don't like the look of what I'm going to have to do here. I do not like it one bit. These aren't remainders now. I mean, to the same extent. So if you split the number of tiles you have into a side length n, you get the other side n with 64 left. But I don't like the maths I'm going to have to do from this point to solve it. Is there another way of doing it? I mean, I've got a really cheaty way of doing it. I could just work out my square numbers. Oh, hang on. Oh, let's try this. So if we do, so yeah, I've got it too. Yeah, so if you know that 5 squared is 25, to get the next square number, you can add a 5 and add a 6. It gets you 36. And so we've got a square where there are a difference of 64 and 25 tiles between the two numbers. You're 64 beyond one square number and 25 below another. So you know the two square numbers are going to be 64 plus 25 apart. They're going to be 89 apart. And so two square numbers that are next to 89 would have to be 44 and 45. So we know n is 44, and 44 squared, I'm going to do 45 squared because it's easy to work out. 45 squared is 2025. So it looks like it's this one. There were 25 too many, I think it's that one. Yeah. If that makes sense. Yeah, so it's basically this is 2n plus 1. So if you do n plus 1 squared, take n squared, you should get 89. That's what you've got there, and you're solving for n. The difference between two square numbers is how many tiles you've got spare. So that's the mathematical way of doing it. I kind of did it just not an elegant method. One of the following is the largest square that is a factor of 10 factorial. Which one? My guess is it's this one. Because 10 factorial only has one 7 in it, and these two will have two 7s in it. So these two won't go into 10 factorial because they'll have 7s in it. So if I can show that 10 factorial is 1 times 2 times 3 times another 2 2's, because that's 4, times 5, times 2 3's is 6, times 7, times 3 2's is 8, times 2 3's is 9, times a 2 and a 5. And my guess is that what you need these to have is the same factors as some of these, not all of them, but you can't have any over. So this will have 2 7s in it because you're squaring it. And there aren't 2 7s in 10 factorial. And the same with this. This will also have 2 7s. So my guess is it's 6 factorial. I'm just going to work out 6 factorial squared. 6 factorial squared is you've got 2 1s, 2 2's, 2 3's, 4 2's, 2 5's, 2 more 2's, 2 more 3's. And now obviously, if it's not this one, because we can just cross this out and check again. So we're going to just cross them off. So 1s don't matter. We've got a 2. I'm going to use a different colour pen. We've got a 2, so green 2. We've got another 2. We've got a 3. We've got another 3. I've got another 2, got another 2, another 2, another 2, 5, 5, 2 more 2s, and 2 3s. Now, if we couldn't do that last bit, it would have been B, but I think it's C. The highest common factor of all the pairs chosen from the positive integers Q, R, and S are 3 different primes. What is the smallest possible value of Q plus R plus S? So we want the highest common factor primes to be small. So if we, this seems fairly easy actually. If you have Q, R, and S, for Q and R to have a common factor, let's say they have a common factor of 2, which means S can't have 2, because they're all different. And if S had 2, then they'd have different common factors. Q and S have a common factor of 3, but not R. And R and S can have a common factor of 5. They're the smallest prime factors you can make. So I think Q is 6, R is 10, S is 15. 6 plus 10 is 15 is 31, which is that. Right, if you've had a go at this yourself and you're a student, an A-level student, this is probably the point that you should be comfortably sort of getting to, and at least from this point now you should have probably had a go at every question sort of. There have been a couple of flaws. My contingent watching have helped me. But now they're going to start getting tough, probably. This already doesn't look nice. The numbers x, y, and z satisfy the equations. 9x plus 3y take 5z is negative 4. And 5x plus 2y take 2z is 13. What is the mean of x, y, and z? So what we're trying to find out is, can we get something to say x plus y plus z, or some factor. If we could get an expression that says like 3x plus 3y plus 3z equals blah, then the mean would be this divided by 9. You divide by 3 to get x plus y plus z, and then you divide by 3 to get the mean. So I think what I'm going to be doing is trying to add or take these equations in such a way that I get the same amount of x's, y's, and z's. Oh, so if we double this, we're going to get 10x, 4y, take 4z, it's 26. And now that's one away, that's one away, that's one away. So we're going to do this equation, take this equation. So we're going to do 10x take, so I'm just going to write that out so you can watch those people who didn't quite get that. All I've done is multiply the first one by 2, because that gets me like a common difference of one of each unit away from what I'm trying to get. Because we know to work out the mean, you have to do x plus y plus z and divide by how many there are. Minus 5z, negative 4. And so now we're just going to subtract these, because if we do 10x minus x, we get x, 9x. 4y take 3y is y, and negative 4z take negative 5z is plus 1z. 26 take negative 4 is 30. So if x plus y plus z is 30, whatever x plus y and z are, x is 10, so the mean is 10. Just as a point, you can't work out x, y, and z unless you get 3 equations. So if you have 2 equations, I know this is a third one, but this is a multiple of that, so it doesn't count. You need 3 distinct equations to work out 3 variables. So simultaneous equations, you have 2 equations, so you can work out 2 answers. If you have 3 variables, you need a third equation. So we couldn't work out what x, y, and z are, but we do know that x and y and z together is 30, which means the mean is 10. Jeroen writes a list of 2019 consecutive integers. The sum of his integers is 2019. What is the product of all the integers in Jeroen's list? Is this as easy as I think it is? If you've got a list of integers, so n plus 1, n plus 2, to whatever, and you've got n plus 2018. For the sum of these to be 2019, some of these will have to be negative. So you're going to have some negative numbers, and negative, 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 and then 0, positive, 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 positive. And then the sum of these, if you've got slightly more positive than negative, will be 2019. But the product of these, you're going to be timesing by 0. So it's negative something times negative something times negative something times 0. It's going to get us 0. Yes, says AJ. That is as easy as it looks. Alison folds a square piece of paper in half along the dashed lines shown in the diagram. After opening it out again, she then folds one of the corners onto the dashed line. What is the value of alpha? Again, I'm just in case I need it. Let's get a slightly larger picture of this. Should probably pre-prepare this if I was excellent. So here we go. So basically, my first thought is, I don't think they're the same length, are they? They can't be. Yeah, they can't, because it's a right angle triangle, so it's not isosceles. So that was my first thought. I wonder if it's easy to open it out. So if we open it back up, that has to be, so that's a right angle. You've got a kite here, because that's also alpha. What am I missing? Oh, no. Put a square piece of green alpha. Oh, it's square. Does that help? If we say that this is 2, the one side length is 2, then this bit here is 1. And this bit is also 2 because it's the top edge folded down. I actually didn't need this blue bit, I don't think. And we're back to what we had earlier, but this time I'm not going to get it wrong. This is 60. And that's 30. How does that help us? Okay, so these two here, this angle and this angle, have to make 90. And because this triangle is basically this triangle, they're the same. So they're both 15. If that's 15, then alpha would be whatever needs to make 180. So 15 plus 90 plus 75 is 180. Oh, I hate these. Oh, please be easy. Which of the following could be the graph of y squared equals sine of x squared? I have no idea what that graph looks like. Right, can we eliminate any? Well, when x is 0, so when x is 0, sine of x squared is 0, so y squared is 0, so y is 0. So that's fine, that's fine, that's fine, that's fine. We can eliminate that one. I kind of want to eliminate this one as well, because I think it should be symmetrical about both axes. Oh, this one isn't symmetrical about both axes, is it? So maybe not. This is definitely symmetrical about the y-axis. This is symmetrical about the y-axis, but not the x. What can we say? So if y squared is that, y is the... Yeah, so y is definitely going to have some negative values. Because y is going to have positive and negative values. So it can't be this one. I think it's between A and C. Oh, hang on. If y is positive and negative this, then it will be symmetrical about both axes. And this one isn't, so it can't be that one either. So the difference between this and this is this has got gaps and this hasn't. Will it have gaps? Can this be negative? Well, x squared can't be negative, but sine of it can be. So if you did, so let's say that x was the square root of 181. Then x squared is 181. Sine of 181 is negative, and y squared can't equal a negative. So I think it's A. Is that right? And the reason that the gaps get smaller is because it cycles through quicker because you're squaring x. But that, I mean, these are getting smaller as well. You definitely can't have. Yeah, so weirdly, if I'd have done this first, it would be between A and D, because I know you can't get. So if x was root of 181, you'd have sine of 181, which is negative. Yeah, okay, Tim agrees. Thanks, Tim. I'm going to... AJ's already marked this, so I'm sure he knows whether I'm right or not. I'll go with that. The heart shown in... So we're now getting close to the last 5 questions. I actually think I've done a good pace today, haven't I? Yeah, I've done a good pace. We've had about half the time, just under half the time. We've got 6 questions left, so... Although these guys have caught at least 2 errors, so thanks very much. The heart shown in the diagram is formed from an equilateral triangle ABC. Equilateral triangle ABC and 2 congruent semicircles on AB. The 2 semicircles meet at the point P. Point O is at the centre of one of the semicircles, so O is the centre of that one. And there lies a point X on the line. The lines, oh, so this line and this line are equal length. What is the angle of, oh my god, there's a lot going on here. Right, okay. I'm going to shrink this because I think I need a bit more space. I'm going to shrink this. So I've got a bit of a larger space to put this picture, and we will get a larger picture there. There we go. Right. Okay. So we know that this line and this line are equal. There's a lot going on here. Which angle ZXY? So we're looking for this angle here. We don't. It looks like it could be 90. We don't know if that's 90, do we? Well, we know this is 60. It's the only angle we know. This is 60 as well. I would take the diagram so that AC was flat. It didn't help. 60. So my guess is that we we can work out the angles in this little triangle here somehow. Because if we can work that one out, we can work this one out. And if we know one of these two, if we know that PZY or ZYX, we can work out the missing one. What does that help? I've just seen a clue from Tim to say circle theorems. Oh, okay. It's the same as this one, isn't it? They're identical because this triangle is isosceles because they're both the radius. I honestly might come back to this one. Yeah, I'm gonna come back to this. I've got like 45 minutes left. I'm gonna come back to it. I'm having a bit of a brain freeze. But circle theorems I've been told, so they're the same because this is isosceles. So what other circle theorems there can be? The angle at the centre is trisect. No, I can't use that one. Okay, I'll come back to it. In a square garden, PQRT of a side length 10. Angle O is double X. It is, yeah. That's tough to see. So basically, if you know your circle theorems, you know this angle is twice that angle. Does that help us? Oh, and then I also know this one in terms of X. That's 180 minus X. I'm going to come back to it. Yeah, I'll explain. Yeah, okay. That's probably enough to start with, actually, isn't it? In a square garden, PQRT of a side length 10. A ladybird sets off from Q. It's a bad square, but it'll do. And moves along edge QR at 30 centimeters per minute. So P, Q, R, T. So the ladybird will do that in red. Sets off from Q and goes that way at 30 centimeters per minute. At the same time as a spider sets off from R and moves along the edge of RT. Spiders are black. At 40 centimeters per minute, what would be the shortest distance between them in meters? So what we're looking for is a line here. where where you're trying to make this line as small as possible. Is there any way we can differentiate it? If we say that if we say that they're moving at that t is a number of minutes gone. So we'll say t is a number of minutes. And this length here is going to be 10 meters minus 0.3 t. And this length is going to be just 0.4 t. And I'm going to undo that. And let's not work with decimals. So let's say this is going to be minus 30t, and that's 40t. And then we want this distance to be as small as possible. That distance is going to be 40t squared plus, I've made the numbers a bit too big here, oh well. Squared, the square root of it is going to be, we'll call that d for distance. This is going to be t squared plus, I made the numbers far too big here, minus 30t times 1,000 twice is going to be 60,000 t plus 900 d squared is d squared. Blech. So I'll just drop 1 0 off each of them. So this is going to be 2,500 t squared minus 60,000 t plus 1,000,000. And we want this to be as low as possible. So we just complete the square. I'm just going to go back and undo it. So take a 0 off each of these. Okay, so complete the square. It's going to be 120. It's going to be a 25th. No, hang on. Being stupid. Alright, let's try again. That's going to say 25 t squared, 25 and 600 is going to be 424. How many 25s in this is 400? And then we want to complete the square with this. It's going to be t minus 12 squared. So 12? Oh, hang on. Yeah, so okay. T minus 12 minus 144 plus 400 is plus 254, 6. So the lowest can be is after 12 seconds. After 12 seconds, you're going to get 25 lots of 256, and you're going to square root it. 256, is that a square number? 25 times 256. So when t is 12, after 12 seconds, this will be 0. And so d squared is going to be the square root of this. The square root of 25 is 5. The square root of 256 is 16. It's going to be 80. But our unit, we went weird, didn't we? Is d squared, so it is d. But we dropped a unit, so that will be 80. That will be, yeah, we dropped some zeros because we were cheating. So it's that one. I don't like my method there, but it worked. We got an answer. Oh no. A function f satisfies the equation n minus 2019, lots of the function, minus the function of 2019 minus n equals 2019 for every integer n. I don't know where to start on this. Don't know where to start. I'm going to come back to it. Find f of 0. I'm lost him. I'm going to come back to it. Oh, the edge length of the solid cube is shown as 2. A single plane cuts through the points y, t, v, and w, which are midpoints of the edges of the cube, as shown. What is the area of the cross section? So there's an interesting thing here that the cross section of a shape like a cube is equal to the number of edges you cut through. So if you cut through 3 edges, you'll get a triangle, and so on. So if you cut off a corner of a square, you've got a triangle because you've gone through 3 edges. In this particular case, you're actually going through, when you cut, if you get a knife and cut down, you're actually also cutting through this edge here. So you're going to go out and in, and you're also going to cut out that edge there. So you're going to go through 6 edges. So I believe the cross section is a hexagon. See you later, Tim. Thanks so much for pointing out the mistakes. So another one that is interesting. An interesting point is if you dangle a cube into a vat of acid, and you dangle it and you keep dropping it until the acid burns away half the volume of the cube, you're left with a hexagonal face for the same reason. So in this particular case, it looks like we've got a rectangle because you're just joining those up, but you're not. You're cutting through diagonally down here and diagonally across. So if the side length's 2, then this length here is going to be root 2. As is this length. It's going to be, we're going to try and work out the area of a regular hexagon with side length root 2. And with a hexagon, you can make up of equilateral triangles. It's root 2, 60, root 2, root 2. So we're going to work out the area of this triangle multiplied by 6. It's going to be half a b sine c. Half root 2 times root 2 is 1. Sine 60 is root 3 over 2. That's one of them, and 6 of those is going to be 3 root 3. Oh my god. The numbers x, y, and z are given by x is that, y is that, and z is that. What is the value of x times y times z? If it wasn't for this other square root, they're congruents of each other. Not congruents. I've forgotten the word now. This is horrible unless you find the trick. X times y times z. So I imagine that this will have an exact value. Alright, I'm going to come back to it. Might find the trick. Two circles. Oh, hang on. What if we square things? Don't get rid of them. Let's try, which is the easiest one? Let's square z. See what z squared is. So it's going to be root 2 plus, so root 2, oh dear. Because would things cancel out? So this times this is going to be 2 plus root 3. This times this is going to be also 2 minus root 3. So that, there's another bit to come, but that simplifies to 4. And then you've got this times this plus this times this, which is the same thing twice. So you're going to be subtracting 2 lots of, does this tidy up? Root 2 root 2 plus root 3 I'm going to lose a minus if I'm not careful, multiplied by negative, so I'm going to put the positive there and put the negative in here. No, I'm going to take the negative out and make this a positive. This is going to be 2 minus root 3. So that bit's 4, and then you're going to have subtract 2 lots of, if you multiply these together, you can use surds to say it's the same as multiplying them in the surds. That's the same as saying square root of 2 plus root 3 multiplied by 2 minus root 3. It's 4. Take 2 lots of, this is going to be the square root of 4 minus 3 is 1 minus 2. So this is 2. Z is 2. Oh my god, how am I going to do that quickly? How can I possibly do that quickly? Is it just going to say, is it just going to be this squared minus this squared square rooted? So that's going to be 4 minus, no, that doesn't work. Am I going to have to do that with each one, AJ? Must be a quick way. How did I get this first bit? Oh no, z squared is 2. So z is root 2. Z is root 2. You made it in terms of A and B. I'm going to come back to it. I think that will work, but there's a lot of maths to do there. Where A is 12 and B is 3 root 7. Oh, I see what you mean. So you're saying that x is root A minus B minus root A plus B. And then you'd squared that. Oh, and that's the same for all of them, isn't it? And then if you square that, well, let's crack on with this, and we've got a method. So we're going to say that x squared is going to be root A minus B minus root A plus B all squared. And all you're doing is replacing 12 with A and 3 root 7 with B. This is going to get you, if you square this, you're going to get that times that. Oh, I'm going to come back to it. I actually think this is making it harder for my head. Alright, I'm probably going to give up soon. I think I'm getting to the point where I'm struggling without help. Two circles of a radius 1 are such that the centre of each circle lies on the other circle. The square is inscribed in the space between the circles. What is the area of the square? Alright. I like geometry questions. Let's give this a Right, okay, what we got? Here we go. Two circles radius 1 such that the centre of each circle lies on the other circle. So the centre of this circle is there. The centre of that circle is there. What is the area of the square? Okay, so I wonder if we can do something like something to do with that in terms of working out lengths. That's not a right angle. It looks like a right angle, but it's not. That's not a tangent. Because if we can work out this and this point, oh, hang on, so we don't know how far apart these are, do we? Yes, they're 1 apart. So that's 1, that's 1, that's 1, and that's 1. Hmm. Nope. Mine's gone blank. Right, so I'm gonna. What time are we at? We've had about 70 minutes. I'm gonna go back to have a look at the ones I've skipped. So where did I start skipping? That one. And then I'm gonna mark it. So I'm not gonna guess at any I'm not sure of. So this one I got a bit of clue from my friends. So I'm gonna erase the pen mark and we'll start from scratch. So this is the angle we're trying to work out. Let's call that x. Because this triangle is isosceles, that's also x. This is 60. This is 60. This is 60. And through circle theorems, the angle at the center is twice the angle at the edge. So this is 2x. And then this is 180 minus x. Don't know if that matters. Which means that's x. Oh, and if that's x, that's 60, that's 120, take x. And then this is 180, take that one, so it's going to be 60 plus x. And this will be 60 plus x because we know that is the same length as that. So we now have a quadrilateral here with all in terms of x, so we can say 60 plus x plus 60 plus x plus 180, subtract x plus 2x is 360. Yeah, okay, so 60 plus 60 plus 180 is 300. X plus x, take x plus 2x is 3x. So x, 3x is 60, so x is 20. Boop. Right. So how many more have we skipped? We've skipped. I'm going to do this one now because we got that. I'm sorry, AJ. I'm actually just going to do it the way I was going to do it. Hey, yeah, I'm shiny. It's because the blue screen pointing at my face. If I make the background, so my face is very shiny. If I make the background any darker, my green screen starts messing up. So I think weirdly light blue. Maybe I can get what's white? Yeah, white's very bright. Light blue, maybe like a dull blue. But then it's not as readable. Oh, okay. Sorry, I thought you meant my face is shiny. Yeah, it is. When I lean forward, it is very shiny. But yeah, that's just too many bright lights. So we're gonna do y squared because that looks easier. Oh dear, what's y? Y is 7 minus 4 root 3. And then it is subtract 7 plus 4 root 3. And we're squaring this. So you're going to get this times itself is going to be 7 minus 4 root 3. You're going to get this times itself, but it's positive, 7 plus 4 root 3. And then you're going to get, I'm going to take the negative out again, so subtract 2 lots of root 7 minus 4 root 3 plus times root 7 plus 4 root 3. Whew. I prefer your way, AJ. It was just messing with my head a bit. So it's going to be 14, they cancel out, subtract 2 lots of, so when I multiply these together, it's the same as saying square root of those two times each other. So 749 subtract 16 3 is 48. Oh, are they all going to simplify to 1? So 14 minus 2 lots of the square root of 1 is going to be 12. So y is the square root of 12. I mean, if x isn't a whole number when you square it, I'm going to get a third of my answer, so maybe I'm going to go wrong. Alright, the last one, x squared, it's going to be, too much going on, 12 minus 3 root 7. Take 12 plus 3 root 7 all squared, which is going to be, this times itself is 12 minus 3 root 7. This times itself is positive 12 plus 3 root 7. Subtract 2 lots of, this is getting to be familiar, 2 lots of 12 minus 3 root 7 times 12 plus 3 root 7. It's going to be 24, subtract 2 lots of, the square root of 12 times 12 is 144. Plus, sorry, subtract 3 root 7 is 9 times 7 is 63. No, 9 times 7, 50. 9 7, 63. 144 take 63 is 81. That's good. 24 minus 2 times the square root of 81, 6. So we think that x is 6, y is root 12, and z is root 2. Root 2 times root 12 is root 20. No. Root 2 times 6 times root 12 times 2. X is root 6, yeah, you're right. X is root 6, I'm still struggling. Unless this, oh no, so 6 times 12, 72 times 244. So it's that. Yeah, because I can't remember the complex conjugate. Yeah, so they're conjugates of each other. It's a mathsy word. So if you multiply these two bits together, they start cancelling out. But I've not seen it within a square root before. But yeah, that's why I squared them. Right, so we've got 2 more to have a go at. My guess is I'm not going to be able to do either of them, so I'm probably going to pass, and I'll show you the answer at the end. I just don't even know where to start on that one. And this one, how many have I got? I'll have a couple of minutes looking at it. AJ solved this one, haven't you, AJ? In your extra time. Okay, if you needed extra time to do it, I'm going to pass. I would have actually had, I think I've got like 10 minutes left. I might go back and check my answers, but I could probably have a go at this one. I just don't know how to start on this. I don't like function notation as a area of maths. So we're going to go back to the start. We're going to mark it. So we're going to get our answers. If I can open up the answers. Alright, okay. These are detailed solutions. Okay, and also if I've gone wrong, I'll correct myself. So here we go. So question 1 is D. Question 2 is B. Question 3 is A. Alright, keep going down. Question 4 is B. Question 5 is also B. Question 6 is D. Question 7 is also D. Question 8 is B. Question 9 is D. That seems like quite an easy one for a senior maths challenge paper. Question 10 is C. Question 11 is also C. And question 12 is E. Question 13 is D. Question 14 is C. Question 15 is B. Question 16 is A. Question 17 is E. That also seems very easy. But I guess if you don't spot it, it's very hard to work out. Question 18 is E. Question 19 is A. We were right. Question 20 is A. Question 21 is D. Question 22, I'm going to come back to that and see if I can talk you through it. Yeah. Question 23 is B. Question 24 is E. I don't have a method here. What have they done? They have done what you suggested, AJ. They've expanded them in terms of the first and the second term, in terms of A and B. They've squared it in terms of A and B, and then they've substituted the bits back in. Okay, and then the last one, if you've done it, is A. So well done if you did the last one. And question 22, if you did it, was C. So the solution, they've suggested you try n is 0. So if you try it effectively f of 0, or n is 0, you get nothing minus 2019 lots of f of 0 take f of 2019 take 0. And that equals 2019. Oh, I see what they've done. Okay, and then basically if you rearrange this, you get f of 2019 equals 2019 lots of 1 minus f of 0. Apologies, 1 plus f of 0. And then if you pick a different value of n, if you did f of 2019 apologies, if you then said n is 2019, what that does, that gets you f of 0 in terms of the other bits, and then you can substitute it in, and you basically get this term to be 2018, I think. You get -2 or something like that. That's how they've done it, but you can have a go at that in your own time. The last one, see what they've done, how have they solved it. So they've done, so if we can clear my working out, so they've done a triangle like and they've extended that to there. They've basically said, since this is 45 and this is 135, my diagram's not big enough. You know this is length 1, and this, from this point to the edge, is length 1/2. And then they've used the cosine rule on this triangle, which doesn't quite go in the square, it hits this point here. They've used the cosine rule with 135, 1.5 to work out this length here. And I think once you then get this length here, you can work out the diagonal of the square and then work out each side. That is tough. That is tough. We're going to go back to the start. We're going to go back to the start and see what we did. So we start with 25 marks. We had a go at 23 questions. We got them all right. So 23 lots of 4 is 92. So we scored 117 out of 125. Yeah, that's it today. Thanks so much for Tim and AJ and anyone else who watched. Sam popped in, Ella popped in, and anyone else who's watching. If you have watched this on YouTube and you had to go yourself, what did you get? Did you get a higher score than me? Did you like some questions? Did you get any questions I couldn't do? I couldn't see how to start those last questions. But that's the senior maths challenge for you. Don't think I've ever got 4 marks on one, but I will one day. Definitely on the time limit. So if you're about to do one at your school and you're practicing, good luck. Let me know how you do. If you just do maths for fun, let me know if there's anything else you want me to do. If you see any other maths challenges you want me to have a go at, I'm going to keep adding to this channel. But otherwise, I will see you soon. Thanks for watching.